nuclear fusion energy, and the competition between the Joe Biden administration and each of Russia, China, and North Korea. Integration in its simplest form. We know that the Sun and other stars derive their energy from an interaction known as nuclear fusion. If this reaction can be replicated on Earth, this could lead to an almost limitless supply of energy. This energy is characterized by being clean, safe, and cheap in order to meet the global demand for energy. A mixture of deuterium and tritium, two isotopes of hydrogen, will be used as fuel for fusion power stations in the future. Inside the nuclear reactor, the nuclei of deuterium and tritium collide and merge, resulting in the release of energy, as a result of this process, from helium atoms and neutrons. But, why is it so difficult to achieve nuclear fusion? 500 years ago, there was a belief prevailing in the Aztec civilization, which flourished in Mexico today. The belief says that the fuel that nourishes the sun, and all the powers emanating from it, is the blood of human sacrifices. Today, we know that this fuel is nuclear fusion, which is the process by which two light atomic nuclei merge to form one heavier atomic nucleus, and this process is accompanied by the emission of huge amounts of energy. Fusion reactions occur when the materials are in a state called the plasma state. Plasma, it is a state in which matter takes the form of a hot, charged gas consisting of positive ions and loose electrons, and is characterized by unique characteristics, different from the solid, liquid, and gaseous states. In order for fusion to take place in the heart of the sun, which shines on our planet, it requires nuclei to collide with each other, at very high temperatures, exceeding 10 million degrees Celsius, to enable them to overcome the electrical repulsion between them. If the nuclei overcome this repulsion, and the distances between them become extremely close, the nuclear attraction between them will reach a level that exceeds the electrical repulsion, allowing them to fuse together. For this to happen, the nuclei must be contained within a small space, to increase the chances of collision. The necessary conditions for the fusion process are achieved in the core of the Sun, due to the extremely high level of pressure, which results from the enormous gravity of the Sun. Nuclear fusion results in the production of a huge amount of energy, 4 times the amount of energy that results from nuclear fission reactions. Fusion interactions can be the basis for fusion power reactors in the future. According to existing plans, the first generation of fusion reactors will use fuel consisting of a mixture of deuterium and tritium, which are two types of heavy hydrogen. In theory, we note that by using only a few grams of these two reactants, deuterium and tritium, an amount of energy equal to 1 terajoule can be produced, i.e. the amount of energy sufficient to meet the needs of one person who lives in developed countries for a period of more than 60 years. Therefore, 1. We find that on Earth, temperatures exceeding 100 million degrees Celsius and extreme pressure are needed to make deuterium and tritium fuse. 2. We also need to provide huge energy to continue and maintain the plasma, in order to keep the fusion reaction going, continuing long enough to heat the plasma. Current situation. 1. The current nuclear fusion reactors, the energy in them reaches a level that may reach a degree very close to the required, but it is not sufficient. 2. What is required is to reach an efficient availability of energy in fusion reactors, and this requires the need to improve the containment and stability of the plasma. 3. Scientists and engineers around the world continue to test new materials and design new technologies in order to bring fusion energy to life. Global collective research. 1. There is ongoing research on nuclear fusion and plasma physics in more than 35 countries. 2. Some fusion reactions have been achieved successfully in several experiments. 3. However, how long it will take to reproduce this process, by which the stars acquire resources, through partnerships and cooperation between countries on a global scale, will depend. Cooperation between countries in the field of nuclear fusion. 1. Since science reached an understanding of nuclear fusion, in the 30s of the last century, scientists have been involved in efforts to reproduce it and harness the energy resulting from it. At first, these attempts were made in complete secrecy. In view of its high cost, it was decided to cooperate between countries with each other. 2. During the United Nations' Second International Conference on the Peaceful Uses of Atomic Energy, which was held in 1958 in Geneva, Switzerland, scientists revealed to the world the ongoing research in the field of nuclear fusion. 3. The agency then launched the Journal of Nuclear Fusion in 1960 to exchange information about the progress made in the field of nuclear fusion, and today this journal is considered the leading periodical in this field. 4. The IAEA's first international conference on the merger card was held in 1961. 5. Since 1974, the agency has held a conference every 2 years to promote discussion on developments and achievements in this field.